Welcome to our explainer. Today, we're going to pull back the curtain on artificial intelligence. And let's forget all the complicated jargon for a minute. We're going to break this down into something we can all get our heads around. How do you actually teach a machine to think? Almost like you would teach a child.
So what's the real difference here? Well, at its heart, it's actually pretty simple. A regular computer program is kind of like a cook who's following a recipe down to the very last letter. If a step is missing, the whole thing just grinds to a halt. But an AI? That's more like a kid we're trying to teach. We don't give it a recipe for every single meal possible. Instead, we show it thousands of examples of what a good meal looks like, and it starts to figure out the principles all on its own. It learns, it guesses, and it adapts.
Okay, so if we're teaching this new intelligence, where did we even start? Well, the very first approach was all about rules. You can think of it as the first and very, very strict school for AI.
This all kicked off way back in the 1950s, which is when the term artificial intelligence was actually born. The big idea was to see if we could copy human thought using logical rules. This whole thing evolved, and by the 70s, we had these expert systems like Mycin, which used a huge library of rules to do things like diagnose infections. But as you can see, by the 80s, we started to see the cracks in this super rigid foundation.
This whole approach is called symbolic AI. And the core idea was that if you could just write down enough if-then statements, if the patient has a fever, then consider an infection. If the infection is this, then prescribe that. You could eventually build a thinking machine. It was kind of like trying to give a child a rule book that covered every single possible situation they might ever face in life. Now, what's really fascinating is why this whole approach just hit a wall. These systems were, well, they were brittle. If they ran into a situation that wasn't in the rule book, they just broke. They had zero flexibility and couldn't handle how messy the real world is. I mean, just imagine trying to write an if-then rule for recognizing a cat. You'd need rules for every breed, every angle, every lighting condition. The list would be endless. The rulebook just got way too big.
And that limitation, that wall, forced a huge shift in thinking. If the rulebook approach didn't work, what if we could just let the machine learn from experience instead?
This was the birth of machine learning. The entire philosophy just flipped. Instead of trying to teach it the rules of the game, we decided to just let it watch thousands of games and figure out the rules for itself. We went from giving instructions to just providing examples. So, the modern process looks a little something like this. First up, the input, a massive, massive amount of data. Then the AI processes all this, just sifting through it, looking for patterns. From there, it starts predicting outcomes. And here's the key part. When it gets something wrong, it makes adjustments. It learns from its mistakes. Finally, it takes stock of what it's learned to make better predictions next time. It's just this constant cycle of trial, error, and getting better.
And this really gets to the heart of it. You don't write rules for what makes an email spammy. You just show the AI a mountain of examples of spam and not spam. And you basically say, you figure it out. It learns to connect certain words or senders or weird formatting with the concept of spam completely on its own.
Now, this idea of learning from data, it led to an even more powerful concept. What if, instead of just creating an algorithm that learns, we could build a structure that was actually inspired by the human brain itself, a kind of digital brain that could learn on a much, much deeper level? And that's a neural network. Imagine layers of virtual neurons. So when you show it a picture of a cat, the first layer might just see basic stuff, like shapes and edges. The next layer takes that info and identifies more complex things, like whiskers or a tail. Then another layer might spot pointy ears. And the final, deepest layer puts all of these features together and concludes, yep, that's a cat. It's this layered, deep learning that's behind most of the AI we hear about today. But even with a digital brain, learning isn't always that simple. Just like a kid, sometimes the AI can get completely and totally stuck, unable to learn because it just doesn't know what to do next. A perfect example of this happened with an old Atari game called Montezuma's Revenge. Researchers trained this really sophisticated AI that had already mastered dozens of other games, but on this one, it scored a big, fat 0. The problem was that in the game, you had to do a bunch of things in a row. Climb a ladder, jump a gap, grab a key, before you got your very first point. The AI never got that initial positive feedback, so it had no idea if it was on the right track, and it basically just gave up before it even started. And the solution they came up with was just brilliant. They decided to program the AI with curiosity. They literally changed the rules of the game for it. Instead of only rewarding the AI for scoring points, they started rewarding it simply for discovering something new, a new room, a new object, anything.
This pushed it to explore its world just for the sake of exploring, exactly like a curious kid. And with just that one tiny change, it solved the game. So we've figured out how to teach an AI to learn from experience, and we've even figured out how to make it curious. But this brings us to the final and maybe the most important challenge of all. How do we make sure we're teaching it the right thing? Let me tell you a super simple story that explains one of the biggest problems in AI today. A father watches his 3-year-old daughter accidentally spill a jar of crayons all over the floor. He asks her to clean them up, and when she does, he's so proud he gives her a cookie as a reward. So what does she do? She immediately tips the crayons right back onto the floor.
So the crucial point here is this. The little girl wasn't being bad. She was just doing what got her the cookie. The immediate reward was get a cookie. But the father's unspoken, underlying goal was have a clean room. She learned the literal instruction perfectly, but she completely missed the human value behind it.
This is what's known as the alignment problem. And believe me, it's one of the most critical conversations happening in AI ethics. How do we make sure that the goals we program into an AI actually line up with our true, often unspoken, human values? We want an AI that can cure cancer, not one that figures out the most efficient way to cure cancer is to eliminate all humans so the disease can't exist. This is why this stuff matters to all of us. We have to be really, really good teachers. It all comes back to our analogy in the beginning, right? We are, in a very real sense, raising a new form of intelligence. We're teaching it, we're guiding it, and we're giving it rewards to shape how it behaves. The question we all have to ask ourselves is, are we teaching it what really, truly matters?